guys, we're back for week 2's podcast of JBS Squared.
We have a special guest.
We have a new
Yeah,
member.
we do have a new member, Selma.
Hello, everyone.
And the question today are basically all about number talks. The first question is, describe one number talk you experienced or designed in class. What kind of student thinking or strategies did it make visible? Anybody want to start?
So I really like the one that's called the comparing one, where we had, like, my group did it with a tree. I'm sorry. Yeah. Oh, it's called Picture It, and it was really cool because you can look at it many different ways. Like, everybody can visualize it in shapes or sizes or colors, and I really like that one. Which one did you guys like the most?
I did which doesn't belong, and then it was just like a square. Like, it looks like what is it called? Like the genetic square thing. What is that name? What is the name of that?
What?
Like when they have like you know what I'm talking about?
Like the application working?
Yeah, like, okay,
Yeah.
that's so unnecessary to talk about, but whatever. I don't know why it reminded me of that, but I had it with 3, 6, 8, and 12.
Mhm.
So that just that whole problem, or like that, what is it called? What is it, like a section? What is it say?
Which doesn't belong.
Yeah, but what is the name of, like, what are all these just number talks, like topics?
Yeah.
Yeah.
I guess. So my topic was, that one is kind of like just reasoning. So, like, regardless if your answer is correct or not, there's not actually a correct answer. It's literally just getting the student, or like us, to be able to prove your, like, use your words, like your reasoning, to prove your answer. So I feel like that's like an easy one for everyone, regardless of age, to be able to prove their answer. Like, that can range from pre-K to adult. So I think it's a pretty good option for if you need something that is like a wide range of age group. I think that's a good one.
Yeah. And I thought it was cool because, like, that one, the which doesn't belong, everybody kind of like had a different answer.
Same. Yeah, when I
Like-
did it with my group, it was the same thing.
Yeah.
They were like 12 because it's a double digit, and then they said 8 because, oh no, they said 3
Yeah,
because it's
which-
odd,
I
because
didn't
it's
even think of
an
that.
odd number.
Yeah.
Yeah, I did. Some of them, I was
didn't
like, where
think
did
of
you get
That's
that
crazy.
from? Oh, and someone said purple because it's not a primary color, which makes no sense because green is not a primary color either. So I don't know what you're thinking.
Wow.
But yeah, I could see that being like good for any age group. Like, even preschool, you could do like pictures.
Yeah, whatever. Apple.
Yeah.
Another one of the number talks is computed the one where they're like, when there's like 4 different ways to, like,
Not 4, but like I guess they give you like a number, like numbers, like a range of numbers, and you try to like find.
Oh,
think
the
it's-
one with 4 was fill the grid.
Oh, is that
But
what
it
it
was
is?
Yeah.
it was basically the same as the computation one, except
I like to fill the grid.
yeah, I like that one.
Cause the same as yours, Brianna, like, everybody thinks about it differently, and like each blocks of the 4 had like a different way of how you can get to that number.
Yeah, like some people, like, for real, like I would have never even thought of
Yeah, no.
doing that. Like earlier, I think it was Stacy. She said the number was 32, and she said 40 minus 8, and that caught me completely off guard. I was like, why would you go higher to
Yeah.
subtract? I was
I
like,
would never even think of subtraction or like anything else.
I would
Other
just
than,
add
like,
them
addition or
yeah, that's it.
I think we're covering the next question already, which talks about how the strategies that surfaced in number talks connect to different points
But I'm
along
not
the
gonna read
learning trajectory.
Trajectory.
And I think we pointed out how a lot of people in our groups and ourselves had different ideas.
Mm-hmm.
And I think this is important because as educators, when we go in the field, obviously the kids are going to be the same way. Everybody's going to come in from a different place with a different idea. So I think,
Yeah, we gotta let them like solve it. We want them to have the correct answer. Like, in general, of course, we want them to have the correct answer, but let them, like, with the number top is the first thing of like the day, or usually like of what's open in the classroom. So I think that's a good way to like get the mind flowing without having so much pressure on them.
Yeah.
So I think it's a good way, like, with no pressure, no grade. So it's a good way to have them like think about things in like an educational, academic way without the pressure. That's what I'm going with. That's what I'm trying to go with.
I think it helps validate kids like thinking and how they get to the answer, and also I'm wondering if that counts as like a form of like pre-testing, like maybe before you teach
Yeah.
something, because
Yeah.
you can see like how kids are thinking
I mean, I think it depends like on which one you use.
of.
Like,
Yeah.
it depends. Like, you can base it on your lesson. So if you need like something that has to do with the tree, like I think it was yours, right? What?
Yeah, that was
Was
a
it
picture.
picture? Like, go ahead and use something with the tree. If you guys are gonna talk about trees later.
Yeah.
But you can use anything that would like give them like to see if they have prior knowledge or something. I think that's a good way.
And
Yeah.
I think these are all good for like misconceptions also.
Yeah.
That's true. What's the next question? How number talk support constructive learning? Is that what it is?
Yeah,
I kind of.
I looked up constructive
Yeah,
learning.
I was gonna say
Okay.
I kind of don't know what that is.
So it is an active student-centered approach where learners build new understanding by connecting new information and prior experiences.
Oh, so kind of what we just said.
Yeah, so
Yeah.
it definitely is an example of constructive learning because like the way we all think about numbers differently tells us what we know prior and tells us about our prior experiences. Like the numbers for make it a grid, I immediately always do like the 10s and then the 1s, and that tells you like I learned that in like
Yeah.
elementary school, and that's like my favorite way to like visualize and think about math.
I think also it gives you ideas. I don't know if that has anything to do with the question, but I think it gives you ideas. If you see somebody else's perspective, it gives me like another idea of how to solve it. Like sometimes I just like go to the simplest way, but sometimes there's like actually a simpler way. Mine was more complicated.
Yeah.
Like for the number talk we had today, like the 18 times 5, I think it was. Like I straight up just did standard algorithm when the 40 plus 50 was probably way easier. Over here, like I was like putting the number in my head.
Yeah.
It would have been easier to just put 10 times. Yeah, like why would I do that in my head? It was probably easier. So I think that's a good way to see like a different or easier perspective, especially for young children. Sometimes they make it harder than what it is.
Yeah.
What's the next question?
So looking like multiplication is like very different than how I learned.
I know there's like so many
they,
ways.
Like, break it down like so far.
It's probably easier.
Yeah.
What is it? Role of form algorithms and how number talks bridge the gap.
Reflect on the
How
role of
bridge
formal
to
algorithms
number
and
So like formal or like that's like standard algorithm, like the stuff we learned like when we were
yeah,
kids. Like long division and stuff.
yeah,
Like I feel like that already went into the second. Like it's just like there's easier ways to do it without having to like get frustrated with it. I think
right.
that's what the question is asking, but I'm not sure.
Yeah. I think in math also it's a very we're used to right or wrong, and then when we do number talks and things like that, we're creating a safe environment for the wrong answers, even though even when Dr. King does the multiplication on the board, she's like, okay, even if you get it wrong, let's see how you got there. And I think that's important to see where the kids like go wrong. And even when you say the problems out loud, you're like, oh, this doesn't look right, or things like that.
Also, I think like it bridges the gap in a way because you're thinking about it in like multiple ways, like how we did the one where it's like compute it. Somebody did like 6 times 3 is 18, but then we also could have done 6 groups of 3.
Yeah, that's
Or
what.
like,
Who was
yeah.
it that did that? Ali or Mackenzie or something?
I
No,
think it
Mackenzie was presenting. I think it was Ali.
Ali was mine. We were
Oh,
both
so
in picture
who was it? The other, I forgot her name.
Oh yeah, we don't know her name.
I don't know her name. She's new. That's the one
Yeah.
that had left. Okay, she said we weren't supposed to be grouping, but she had grouped, like made. You know how multiplication is like groups of a.
Yeah.
Groups of a group.
Yeah,
Or like 3. I don't know how to. Damn.
I don't know how to explain it either.
But it was like
Part
okay,
of-
so is it part of a group? I don't know. But instead of doing 6 times 3, she did like 3 circles and then the 6 on the inside. I think that's what she had done.
yeah.
Yeah. So, or like, is it like repeated addition?
Yeah, but it
Yeah,
was just
that's
like
what we
instead of like having the numbers out, she like visualized it like how you would when you were a little kid. You would draw it.
Yeah.
So that was like a different way. I guess like I didn't think about it until I saw it. I'm like, okay, that makes sense. Like, maybe I should have thought about it.
I know. When I was in field work, that's how they were doing
What grade do
like
you have?
addition, first grade.
Oh, that's why.
Which I'm like,
they were
Like,
drawing.
obviously you can't remember that young, but I'm like, how did I learn how to like?
I think they
add
really
and
just
subtract?
they taught us like literally like standard, like everything was like really standard. I don't remember doing
Right?
any type of grouping when it came
Also-
to multiplication.
I don't remember having like number talks.
No,
No,
we definitely did
no.
not have that.
Like, I
Definitely
mean, my
not.
school was like. But
I had like, we definitely use manipulatives and
Whiteboards. That's what I remember using. A
yeah,
whiteboard.
whiteboards.
But my school like literally would divide us in half and like
By
have
what?
our desk space the other way. And half the class would be like the A group, which is like the smart group, and then I was in B group because I was in the dumb group.
Oh my god.
And yeah, it was crazy. We literally like couldn't even like talk to each other
That's
across the
not
classroom.
fair.
It's crazy.
That separation is insane.
Was that private school?
Yeah, bro.
They could do whatever they want.
I only remember when I was in school in Egypt, multiplication was by memory. And then when I came to the US, it was also like, we did like computer programs like fast math and things like that.
Mhm.
It was like, whoa,
A little too fast, man.
yeah.
No, but because here it's like we have to learn our multiplication table, obviously, because how are we gonna do like if it's like we're doing a double digit, we need to know like what the 2 times 6 is,
Yeah.
and then the rest like then we have to learn how to do the math because the rest is like doable. I don't know how to explain that, but it's like it doesn't come as naturally as knowing the times table. Like you know 2 times 4 is 6.
Yeah.
Or the easy addition, 2 plus 2, 4.
Mm-hmm.
2.